What if the universe isn't just expanding, but evolving? Not randomly, not chaotically, but carefully, silently, solving its own problems with every breath of starlight and curve of gravity. What if everything, from the tiniest particle to the largest galaxy, is part of a pattern that fixes itself as it grows? Tonight, as you drift among the stars, let's ask the question no textbook dares to answer plainly. Does the universe know what it's doing? Maybe not in the way we understand, but maybe in a softer, older language. One written in spirals and symmetry, in heat and harmony. And if you stay with me, quietly, until the end, you might just feel the answer, not in facts or formulas, but in the way everything holds together, even you. In the beginning, there was no balance, only boundless chaos, raw and unwound, expanding into a space that had never existed before. It was not a spark, not a flash of creative brilliance, but something deeper and stranger, a silent roar, a blooming of pure energy that unfolded in every direction at once. There were no stars to shine, no atoms to hold hands, no time to measure what was happening. Space itself was stretching and trembling, freshly born, like a vast sheet still shaking from its release. The newborn universe had no symmetry, no stability, no rules. Particles collided and vanished, energy surged and scattered, and even the concept of a beginning was still trying to find a place to stand. It was heat without shape, motion without reason, noise without sound. Everything was new, everything was unstable, and yet everything was possible. But even in that wild infancy, something remarkable began to emerge, not by force, but by a kind of quiet agreement written into the laws we hadn't yet discovered. Gravity began its slow, invisible work, pulling, gathering, weaving things closer, like a soft hand taming a frayed thread. Time, though still young and uneven, started to settle into a rhythm. Across the endless dark, symmetry began to appear, not perfect, but enough. Enough for electrons to orbit, for forces to find balance, for light to find a path through the dark. The particles that once screamed past one another now began to linger, to combine, to create, and so, the universe, chaotic, unwatched, unguided, started to solve its own chaos. Not by fighting it, but by flowing with it. Stars were not placed, they were born from collapse and pressure, tiny furnaces lighting up the dark with answers. Galaxies spiraled not by design, but as a natural solution to motion and gravity learning to share space. Even black holes, those great swallowing mouths of silence, became part of the solution, a cosmic recycling of matter and momentum, not an ending, but a reshaping. It's easy to think of the universe as indifferent, cold, random. But maybe it's not. Maybe it has always been softly, patiently repairing itself. Fixing tension with expansion, disorder with pattern, loneliness with light. Not consciously, not like us. But faithfully. Gently. Perhaps that's what reality is, not a finished product, but an ongoing act of self-correction. A kind of cosmic wisdom baked into the bones of being itself, and as you float here tonight, eyes closed, mind open, remember this, the universe didn't begin perfect. It became gentle through time. And it continues to become, with every breath, every orbit, every slow, spiraling solution. Maybe we, too, are part of that long, quiet answer. It's almost impossible to imagine how the universe, in all its wildness and unformed fury, somehow began to shape itself without ever being told how. In those first moments after the Big Bang, there were no galaxies to light the dark, no planets spinning in rhythm, no atoms even stable enough to hold hands with each other. Everything was heat and violence, a storm of creation where particles flickered in and out of existence like candle flames caught in a hurricane. There were no instructions. No paths to follow. Just motion, noise, and infinite possibility, so tangled it seemed impossible that anything coherent could ever come of it. But within that madness, within the formless hum of expanding space, the universe was already beginning to whisper to itself. Quietly, delicately, it started to solve the problem of its own chaos. First came the cooling. Not quickly, not suddenly, but gradually, as if the universe, overwhelmed by its own energy, exhaled. With cooling came calm. And in that calm, the forces that still govern us today began to emerge like old friends returning from a dream: gravity, electromagnetism, the strong and weak nuclear forces. Gravity in particular became the quiet weaver, the silent arranger. It didn't bark orders. It pulled softly. It convinced particles to come closer, to try again, to hold on a little longer. And over time, unimaginable time, those tiny, flickering particles began to bond, to orbit, to trust the space between them. From hydrogen and helium, the lightest of all elements, the first building blocks of stars were born, and those stars, they didn't just shine. They cooked. They took in hydrogen, crushed it in their hearts, and fused it into helium, then into carbon, then oxygen, then iron. Stars became the universe's first alchemists, turning simplicity into complexity. They burned and pulsed and sometimes exploded, scattering their heavy, newly formed elements into space like seeds in a vast, dark garden. Each supernova was violent, yes, but also necessary. A problem solved by release. A system restarting itself. And from the dust of those dead stars came planets, moons, oceans, and eventually, the quiet chemistry of life. You see, the universe never stopped being chaotic. It simply learned how to dance with its chaos. It didn't remove disorder, it used it. Feedback loops evolved, where change became adaptation, and failure became refinement. Galaxies spun into elegant spirals not by plan, but by pressure and chance and time. Life on Earth emerged not from certainty, but from endless trial and error. Even now, stars form and die, tectonic plates shift, species evolve, storms rage and calm, not because someone controls it, but because everything is connected in a slow, unfolding logic that doesn't need permission to be beautiful. So when we say the universe solves its own problems, we don't mean with intention. We mean with rhythm. With memory. With rules so subtle they feel like magic. The kind of solving that takes millions of years, and leaves no blueprint, only beauty. A galaxy doesn't know it's spinning perfectly. A tree doesn't realize its roots follow gravity. But they do. Everything follows. Everything participates, and tonight, as you lie back and drift beneath your own little corner of sky, let this truth hold you gently: the same quiet intelligence that organizes stars is alive in you. In your breath. In your heartbeat. In your ability to adapt, to feel, to rest. You are not separate from this cosmic unfolding. You are its latest expression. Its softest problem, already solving itself in the silence of sleep. Gravity is not a force you can touch or see, not a sound you can hear or a light you can follow, and yet, it is everywhere, always, solving the universe's deepest problem: how to bring what is scattered back together. In those earliest moments after the Big Bang, everything rushed outward in a great exhale of creation, wild, unstructured, and completely free. But with that freedom came separation. Particles fled from one another, energy dispersed across the void, and the young universe became a place of distance, not belonging. Yet hidden within that chaos was gravity, a force not of noise but of longing. It didn't scream to be heard. It didn't need to. It waited, ancient, invisible, inevitable. Slowly, it began to gather the pieces. Dust clouds thickened, swirled, and spun under its pull. Matter curved around itself, not because it was forced, but because gravity gently persuaded it to come home. Where things once moved apart forever, gravity offered something new, a reason to stay. It is through gravity that the first stars ignited, not randomly but as a direct result of matter collapsing inward under its spell. These stars, burning bright in the vast dark, became more than just light. They were the universe beginning to know itself, to shape itself. Gravity didn't stop there. It continued to guide the birth of galaxies, not designing them with blueprints, but shaping them through a patient, silent negotiation between matter and motion. It allowed for balance, orbits formed, systems stabilized, worlds found paths around their stars. Even now, billions of years later, gravity still does this work, holding planets close, curling the arms of spiral galaxies, anchoring massive clusters across distances too immense to comprehend. And what's most remarkable is how soft this force truly is. It has no sharp edges, no fury. It moves through everything like a gentle tide, quiet, constant, and unrelenting. It touches you, too. Every step you take, every time your feet return to the ground, every ocean tide, every moment of stillness in the vastness of space, that's gravity. Not restraining, but embracing that it solves without struggle. It pulls without pain. And in doing so, gravity became one of the universe's most elegant solutions, the answer to endless expansion. The glue that turned chaos into cosmos. It does not stop change, it gives change direction. It does not destroy motion, it gives it rhythm. It holds galaxies like cradles, stars like candles, and your body like a lullaby whispered across space. So when you look up into the night sky and see planets drifting, moons spinning, galaxies flowing like frozen rivers, know that this is gravity at work. Not commanding. Not correcting. Just helping everything remember where it belongs. Symmetry is often mistaken for stillness, for frozen perfection, but in the hands of the universe, it became a canvas for transformation. In the earliest seconds after the Big Bang, the cosmos was ruled by a profound, elegant symmetry. There was no difference between the forces we now know, gravity, electromagnetism, and the nuclear interactions were not yet separate identities. Everything behaved in harmony, as if reflected across a great cosmic mirror. Matter and antimatter were produced in equal amounts, particles had matching opposites, and every direction of space looked the same as every other. It was a universe without preference, without contrast, without conflict. This balance was not just visual, it was fundamental, woven into the laws that governed the young universe like a tightly tuned melody, each note echoing its twin, each law supporting the whole in perfect resonance. It was the kind of balance that feels sacred, like something too complete to ever change. And yet, to remain that way would have meant nothing more could happen. Perfection, for all its beauty, is silent. Still. Closed, but the universe was never meant to be still. In an act as quiet as it was monumental, that flawless symmetry fractured, not in violence, but in possibility. The forces of nature began to drift apart, to specialize. Gravity fell away first, becoming the weak but far-reaching sculptor of space. The strong force remained bound to the heart of atoms, and electromagnetism stretched out its arms toward light and charge. The world of physics began to diverge into roles, like instruments in an orchestra once fused in unison now taking on their own melodies. And with this breaking, the universe took its first real breath of diversity. Imperfection was no longer a flaw, it was the key. Tiny imbalances appeared, like an uneven weight on a perfect scale, and those tiny irregularities became seeds. One extra particle of matter here, one fewer particle of antimatter there, almost nothing, yet just enough. Enough to tip the scale. Enough to make matter dominate. Enough to ensure something would remain after the fire cooled. This gentle crack in symmetry gave time its direction, space its texture, and nature its personality. Because of that imbalance, atoms could form. Because of that break, stars could ignite. Because of that tiny tilt in the structure of everything, life could rise, wonder could evolve, and you, sitting quietly now under your own night sky, could begin to ask why. The universe didn't abandon symmetry, it simply stepped beyond it. It used balance not as a destination, but as a doorway. And through that doorway flowed everything else: complexity, contrast, motion, choice. A cosmos in perfect balance would have remained beautiful and empty. But our universe chose a different kind of beauty, the kind that lives, that grows, that changes. And so, in solving the problem of stillness, the universe gave itself a story. A story written in light and shadow, in attraction and resistance, in the tiniest imperfections that made all the difference. Feedback loops are the universe's quiet way of staying aware, not through consciousness as we know it, not through eyes or language, but through rhythm, adjustment, and return. In a cosmos without a central mind, without anyone to oversee the balance between chaos and calm, feedback loops serve as the universe's internal dialogue, a built-in intelligence that allows it to respond to its own changes. These loops don't shout. They don't control. Instead, they whisper, slowly, gently, guiding the unfolding of systems through cause and correction, push and pull. When something grows too fast, another part slows it down. When something becomes too cold, another process warms it up. In this way, the universe does not need a plan. It needs only attention, the kind of attention that listens through action, that shapes through response. You can find feedback loops across every layer of existence, from the spiraling galaxies to the living skin of a single cell. In galaxies, massive stars form from collapsing clouds of gas, burn brightly, and then send out winds and radiation that push surrounding gas away, preventing the birth of too many stars too quickly. In this way, the galaxy regulates its own expansion, ensuring it doesn't burn itself out too fast. This isn't intention, it's balance born from repetition, from interaction. It's the cosmos learning how to pace itself. In stars, nuclear fusion heats the core, and that heat pushes outward, balancing the inward pull of gravity. If the balance tips, the star either expands or collapses, adjusting itself until it finds stability again. Over billions of years, these loops create lifespans for stars, determining when they shine, when they cool, and when they die. On Earth, feedback loops govern the dance of ecosystems. Populations rise and fall not randomly, but in response to each other. A surge in predators leads to a decline in prey, which in turn leads to fewer predators, allowing the prey to recover. Climate, too, breathes in loops. Ice reflects sunlight and cools the planet. Less ice absorbs heat and warms it. Forests grow, absorb carbon, cool the air. They burn, release carbon, and tip the balance back toward heat. These aren't just reactions, they are relationships. Loops within loops, systems within systems, each one echoing the others in a cosmic choreography that requires no rehearsal. Even your body is part of this larger language. Your heartbeat slows when you rest and speeds when you run. Your body cools itself with sweat, warms itself with shivers, maintains its balance not by accident, but by the quiet logic of feedback. What makes feedback loops so powerful is that they allow for adaptation. The universe doesn't need to be perfect, it needs to be able to notice. These loops are how it remembers the feel of balance. They allow for complexity without collapse, for motion without madness. Instead of crashing from its own unpredictability, the universe folds that unpredictability into the way it learns. It fails safely, and tries again. And over time, it builds structures, galaxies, planets, oceans, minds, that hold their shape not because they are rigid, but because they are responsive. That is the real miracle, not that the universe avoids change, but that it welcomes it, listens to it, and shapes it into something steady. So when you think of a self-correcting universe, think of this, not a perfect machine, but a living rhythm. A pulse that changes with time, with temperature, with tension, but never stops. The universe doesn't solve problems by resisting them. It embraces them, listens to their echoes, and slowly learns how to hold them in balance. Not forever, but for long enough. Long enough to make stars. Long enough to make life. Long enough to make you. The mathematics of self-correction is not a rigid formula stamped onto the universe, it is more like a song the cosmos keeps remembering how to sing. From the vast sweep of galaxies to the spiral of a fern, mathematics doesn't force nature into shape, it emerges gently, again and again, from nature's own desire to function, to grow, to continue. It's easy to think of math as something external, invented by humans to measure and manage the world. But what if it's the other way around? What if math is the world's original language, quietly organizing existence beneath the surface, long before anyone gave it names or symbols? The universe, in solving its problems, doesn't choose math. It is math, unfolding patterns, proportions, symmetries, and relationships with every breath it takes. Fractals, for instance, are not rare. They are everywhere. They are the fingerprints of self-organization, patterns that repeat at every scale. Look at the way lightning branches through the sky, the way blood vessels weave through your body, the way rivers carve the land, all of them echoing the same recursive structures. This isn't mimicry. It's efficiency. Fractals solve the problem of reaching the most space with the least effort. They allow nature to grow without reinventing itself at every turn. They are nature's way of saying, "This works. Let's do it again, but bigger, or smaller, or softer." Even chaos, when viewed through the lens of fractal mathematics, reveals underlying structure. The things we call messy, clouds, mountain ranges, coastlines, are not failures of order. They are successes of complexity. They are what happens when the universe allows variation to thrive within boundaries. Then there is the Fibonacci sequence, that quietly magical string of numbers where each value is the sum of the two before it. It seems so humble, so simple, and yet this numerical rhythm appears in sunflower seeds, pine cones, galaxies, and hurricanes. It shows up in the spiral of a snail's shell and the arrangement of leaves on a stem. Why? Because this pattern allows things to grow evenly, to distribute energy and space in a way that is both beautiful and practical. The golden ratio, woven deeply into Fibonacci, creates shapes and proportions that the human eye finds pleasing, not because we've been taught to admire them, but because we are made of the same math. Our bones, our faces, our DNA, they echo the same ancient patterns written into the stars, and this is what's most profound: these patterns aren't imposed. No one tells a fern to grow in a spiral. No architect tells a galaxy to curve its arms just so. These forms arise naturally, through feedback, trial, and gentle correction. When the universe stretches too far in one direction, it coils back. When something grows unevenly, the pattern redirects. Math becomes a kind of memory, not a strict script, but a soft reminder. It guides without dictating. It teaches the universe how to try again, how to refine its gestures. Evolution itself, with all its randomness and mutation, works because of feedback and pattern. Even mistakes become part of the logic, absorbed, adapted, used. And so, over time, the universe learns how to arrange itself. How to find shapes that work. Not through thought, but through iteration. Not with precision, but with patience. So when you look at the spiral of a galaxy, the veins in a leaf, or even the symmetry of your own body, you're not just seeing math, you're seeing the universe solving the problem of existing gracefully. Of turning raw possibility into lasting form. It doesn't do it all at once. It stumbles, adjusts, tries again, and in doing so, it writes the poetry of existence in numbers, curves, and forms. Math is not the universe's code. It is its conversation. A language of trial and echo, of rhythm and return. A promise that even chaos, given time, will find its shape. Stars are not merely lights in the sky, they are the universe's first artists, engineers, and storytellers, living solutions to the most ancient question of all: how does matter become meaningful? In the early chapters of cosmic history, before stars were born, the universe was a cold, dark ocean of potential, clouds of hydrogen and helium drifting without purpose, particles bumping into each other without forming anything stable. But then came gravity, drawing those clouds together with a gentle, persistent pull. As the gas compressed under its own weight, pressure and temperature rose until, deep within the core, atoms began to fuse. And when that first reaction sparked, when hydrogen atoms collided and merged into helium, the universe experienced something brand new: light from within. Not the reflection of some outside flame, but light born of transformation. Stars were the first structures that didn't merely exist, they did something. They converted mass into energy. They glowed. They warmed. They created, and from that glow came everything else. Stars are not static monuments to beauty, they are living factories, processing the simplest elements into complexity. In their hearts, fusion turns hydrogen into helium, and as stars mature, into carbon, oxygen, nitrogen, silicon, and iron. These aren't just elements, they're the ingredients of breath, bone, ocean, blood, tree, cloud, and memory. Without stars, there would be no carbon in your cells, no oxygen in your lungs, no calcium in your bones. Every element heavier than hydrogen was forged in a stellar furnace. And when massive stars reach the end of their lives, they don't go quietly. They explode in brilliant supernovae, scattering these elements across the galaxy like seeds in a cosmic garden. Their deaths are not ends, they are beginnings. The iron in your blood, the gold in a ring, the calcium in your teeth, all of it once floated in the heart of a dying star, but stars don't just solve the problem of element creation. They solve the problem of time. Stars are clocks, slow, patient clocks that measure billions of years with each pulse of fusion. Their lifespans dictate the rhythms of galaxies. The heat and light they emit stabilize planetary systems, giving rise to climates, to seasons, to life. Their gravity shepherds comets and planets into orbits, shaping solar systems into organized families rather than scattered debris fields. Even the smallest stars, red dwarfs, barely flickering in the cosmic night, burn slowly for trillions of years, providing warmth and stability longer than our own sun ever will. They are the heartbeat of the universe, pulsing softly in the dark, marking the passage of time long before time meant anything to us. Stars are teachers, too. By observing them, we have learned to read the language of light. We've discovered their age, their chemistry, their history, and through them, our own. They hold records of what the universe was like billions of years ago, their light traveling for eons to reach us. Every star you see in the night sky is a message from the past, arriving at your eyes like a postcard from a time before Earth even existed. And some of them, having already died, shine only in memory, their final gift, a shimmer across the blackness that reminds us that even after death, something can remain. And so, when we say stars are how the universe solves its own problems, we mean this. They bring order to chaos, light to darkness, complexity to simplicity, meaning to matter. They show the universe how to grow up, how to burn brightly, how to let go when the time comes. They are not accidents, they are the natural, inevitable flowering of a cosmos that refuses to stay still. Each star is a lesson in persistence. A quiet reminder that even cold gas can become radiant, that even darkness can be answered with light, that even death can become the soil for something new. When you look up tonight, know that you are not just looking at stars. You are looking at history. At chemistry. At memory. At everything the universe learned to become, by simply letting itself shine. Black holes, the great recyclers, not monsters, not destroyers, but quiet architects of rebirth. For a long time, black holes were cast as villains in the story of the universe, bottomless pits that devoured everything in their path, even light itself. But this image, while dramatic, misses something much more profound. Black holes are not simply the endpoints of dying stars, they are part of a larger cycle, a cosmic feedback loop where creation and destruction are just two sides of the same process. When a massive star runs out of fuel, gravity collapses its core into a point of infinite density, a singularity, and around it forms the event horizon, that invisible veil beyond which nothing returns. But what we often overlook is what this collapse does for the universe. It clears space. It compacts mass. It shapes galaxies. It resets the board. At the centers of nearly every galaxy, including our own Milky Way, lies a supermassive black hole, millions to billions of times more massive than our Sun. These giants are not passive. They organize the motion of stars, influence the growth of galaxies, and regulate star formation through powerful jets and radiation that emerge from their swirling accretion disks. As they consume matter, they don't just vanish it. Some of that matter, heated to extreme temperatures, is blasted back into space in colossal streams of energy and particles, seeding interstellar space with the ingredients for new stars and systems. This is not destruction. It's cosmic pruning. Black holes help the universe recycle its matter, redistribute its energy, and sculpt its future. In their silence, they are sculptors. In their hunger, they are gardeners. Where we once saw only endings, we now see deep, essential beginnings, proof that even in the darkest places, the universe is still finding ways to transform. Life is not a mistake, nor a miracle that stands apart from nature. It is nature solving its most delicate and personal problem: how to preserve itself. When Earth cooled enough to form oceans, and chemicals danced in warm, mineral-rich waters, something strange and astonishing began to happen. Atoms joined into molecules, molecules into chains, and within those chains appeared structure, not rigid, but full of potential. Among these molecules was something that didn't just exist, but remembered. That molecule was RNA, and later, DNA. Not simply matter, but information. Not just atoms, but a code. A living blueprint that could copy itself, evolve, repair, and adapt. DNA was not designed, it was discovered by nature through endless trial and error, through the quiet testing of every arrangement, until one worked. Until one could last. What makes DNA so breathtaking is not just its complexity, but its humility. For simple letters, A, T, C, and G, combined in billions of ways to describe everything from a leaf to a lion. It's a code that isn't written in ink but in chemistry, and it solves the problem of death not by avoiding it, but by surviving it, through replication, mutation, and inheritance. DNA does not cling to perfection, it embraces error as a tool. Every mistake is a question: could this be better? Could this survive? And through this slow, sacred process, life emerges. Cells learn to copy themselves. Organisms adapt to their environments. Nervous systems form, brains begin to think, and eventually, one species, ours, begins to ask where it all came from. In the elegant twist of the double helix lies the universe's most intimate answer to entropy: to live is to learn, to remember, and to try again. DNA is the signature of a universe that not only changes, but wishes to endure. Survival isn't just endurance. It's curiosity. It's nature asking, over and over again, what if, and then watching quietly to see what works. Evolution is not a straight path or a rigid plan, it's a slow dance between chaos and order, trial and adjustment, loss and learning. From single-celled organisms floating in ancient seas to the intricate minds that now reflect on their own origins, evolution is how the universe writes and rewrites the code of life, refining it across billions of years. Mutation introduces new possibilities, small, random changes in DNA. Most lead nowhere. But sometimes, a tiny shift grants an edge: sharper eyesight, better camouflage, stronger lungs. And nature remembers what works, not with intention, but with consequence. Those who survive pass their advantages forward, and slowly, life becomes more complex, more aware, more connected to the environments that shape it. Evolution doesn't seek perfection, it adapts to the moment. Giraffes stretch their necks not to become ideal, but to reach leaves higher in the trees. Arctic foxes grow thick white fur not for beauty, but because the cold demands it. Even within us, our opposable thumbs, our deep memory, the emotions that bind us to each other, are remnants of millions of small decisions made by nature through time. Evolution is the universe's longest-running experiment, and every living thing is a note in that song, a response to pressure, to change, to survival. It's how life solves the challenge of a shifting world, not by resisting change, but by becoming it. And the story is still being written, in birds learning new songs, in bacteria adapting to antibiotics, in us, dreaming of stars, wondering what will become next. Somewhere between stardust and thought, the universe did something extraordinary: it opened its eyes. It built a mirror from neurons and breath, and in that mirror, it saw itself. Consciousness isn't just a side effect of biology. It's the most delicate solution to the most intimate problem the universe ever faced: how to know that it exists. For billions of years, stars burned and galaxies danced, but none of them paused to wonder why. Then, in the quiet folds of a blue planet's forests and oceans, something stirred: first a flicker of sensation, a response to light, a twitch at the touch of heat. Over eons, these sparks became systems. systems became selves. And at some unknown moment, a creature, maybe not human, maybe something much older, felt not just the world, but itself. This awareness wasn't loud. It didn't arrive with fireworks. It emerged slowly, as if the cosmos had been whispering to itself all along, and finally learned to listen. Consciousness let the universe reflect. It gave rise to memory, to emotion, to questions no other force had ever asked. What am I? Why does any of this exist? What happens when it ends? In humans, this awareness became art, love, sorrow, wonder, not survival tools, but expressions. Symbols of a cosmos that now dreamed within its own patterns. And while consciousness feels private, even fragile, it connects us to something vast. You are not separate from the stars. You are their echo, atoms forged in stellar cores, arranged in a way that can laugh, weep, and imagine. You are the universe thinking, feeling, hoping, the universe becoming aware of the universe. And that might be its most beautiful solution of all. For all its brilliance and quiet intelligence, the universe has not revealed all its answers. In fact, the deeper we look, the more we realize how much is still cloaked in mystery. There are parts of reality, vast, persistent parts, that defy every theory we've built so far. Take dark matter, for example. It's invisible. We can't touch it, can't see it, can't capture it in a lab. And yet, galaxies spin too fast to be held together by visible matter alone. Something is out there, adding mass without showing its face. It doesn't shine. It doesn't interact with light. But it shapes galaxies, bends starlight, and makes up most of the matter in the cosmos. In a universe where light gives us knowledge, dark matter is a quiet refusal, a reminder that not everything needs to be seen to be real. Then there's entropy, the slow, inevitable drift of order into disorder. It tells us that even the most beautiful systems unravel over time. Stars burn out. Structures decay. Heat spreads. The arrow of time moves forward not because the universe is in a hurry, but because entropy insists on it. It's not chaos for the sake of destruction, it's the cost of complexity. Every choice, every creation, every thought carries a price. A little more disorder elsewhere. And yet, even as things fall apart, the universe keeps creating. Stars are born, cells divide, people fall in love, small rebellions against entropy that suggest something deeper may still be at work, and at the smallest scale, quantum uncertainty waits like a quiet riddle. In that strange realm, particles do not exist in one place, but in many, until you look. The act of observation itself seems to change reality. Cause and effect blur. Certainty collapses into probability. And yet, from this fog of maybes, stable worlds still rise. Chairs remain solid. Hearts keep beating. Suns keep shining. These mysteries, dark matter, entropy, quantum weirdness, are not failures. They are invitations. They are the universe saying, you've come far, but not all the way. They remind us that we live in a reality that is still dreaming, still shaping itself, still full of secrets waiting in the dark. What if the universe isn't trying to solve anything at all? What if, instead, it's simply becoming, not fixing problems, but unfolding into deeper complexity, richer texture, and quiet beauty? From the outside, it may look like nature is constantly correcting itself, repairing imbalances, responding to instability. But maybe that's just the rhythm of something that's growing. Like a seed sprouting roots and leaves, not because it was broken, but because that's what it was always meant to do. Maybe stars didn't form to solve the problem of darkness, they were simply the next breath of a deepening cosmos. Maybe life didn't emerge to repair emptiness, but because the universe had finally found a way to feel itself, to taste, to touch, to wonder. The story of the universe isn't a straight path from disorder to order, or from chaos to calm. It loops. It weaves. It dances. It creates time, then erases it in black holes. It builds atoms, only to break them apart in stars. It forms galaxies, then scatters them with dark energy. There is no perfect state it's trying to reach, only the continual unfolding of what is possible. Like music that doesn't seek a destination, but expresses something along the way. Like a painting that keeps layering color, not to fix what was wrong, but to explore what could be. Maybe the universe isn't a puzzle to be solved, but a story told in waves and stardust, in silence and sound, in the slow bloom of a conscious mind beneath a blanket of stars. And if that's true, if it's not solving, but becoming, then perhaps we are not mistakes, not solutions, not problems. We are moments in the flow. Brief, glowing notes in the universe's endless song. Not separate. Not outsiders. But part of the melody. Part of the becoming. Part of the beauty that doesn't need to be explained, only felt. Maybe we don't need all the answers. Maybe the mind can rest knowing that the universe doesn't always speak in sentences, it speaks in seasons, in spirals, in quiet corrections and endless motion. There is something deeply comforting in the thought that we are held by patterns far older than thought itself. That long before we knew how to wonder, stars were already pulsing, oceans were already breathing, and gravity was already writing its soft, silent logic across space and time. Maybe the goal was never control, but connection, not perfection, but rhythm. So tonight, as you drift into sleep, imagine yourself not as a separate thing, but as part of that rhythm. A thought the universe is having. A flicker of awareness in its long, glowing dream. Maybe it's enough to float inside something that's always working, always becoming, always gently holding itself together. Let go now. The cosmos has you.